Good evening. Good evening, Favor. If you are joining me for the first time, we want to look at two aspects of chemistry practical. This class, we're going to look at the volumetric analysis, which involve the titration, and we're going to look at source analysis. So if you are joining now, I have just written some questions on what you should be expecting. These questions are what you should be expecting based on what you have been given in your yellow paper. Now, your yellow paper, you have been given an acid and a base. And the acid that you have been given is what? Tetraozo sulfate 6. And base being given is what? Sodium hydroxide. You are given this one in purity. You are asked, this one is 5.6 cm cubed of 1.84 relative density, and the purity is 98%. Because of that purity, the question Waec will likely ask is what? Calculate the percentage of what? Purity. That is why in our question we have brought this one here. Are you following? Are you following? Now, what I need you to do is that critically write down the question. If you can screenshot, thank you very much. If you can screenshot, make sure you screenshot this, because after now we are going to wipe out. This portion. If you can screenshot, you screenshot. But this live video will be saved so that anytime you want to revisit this YouTube channel, you can also revisit it. If you are not subscribed, do well to subscribe. Now the question says A, which is the acid, all right, is a solution of 5.0 grams. Is a solution of what? 5.0 grams of what? Tetraozo sulfate acid in what? 500 cl cubed. B is a solution containing what? 4.0 grams per dl cubed of what? Sodium hydroxide. Titrate A against 20 or 25 cm cubes. This 20 or 25 is your burette. That is your pipette. What you use in pipetting your base. And in normally most laboratory, what they normally use is 25. And the one that we are going to use is 25, not 20. Now, portion of what? B, using metal orange as what? Indicator. We are now asked to repeat the titration 3 more times. We are going to repeat the titration 3 more times and record your result. From your results now, you are now asked to do what? Calculate 1, the average volume of acid. Number 2, the concentration of base in moles per dm cube. Look at base is given in what? Grams per dm cube. And now you are now asked to calculate what? In moles per dm cube. Are you following? And the second one, that is the third one, you are asked to calculate the concentration of A in moles per dm cube. A here is given in grams per what? Cm cubed. Gram per cm cubed, not gram per dm cubed. So we need to convert this gram per cm cubed to what? Grams per dm cubed before you can now begin to work. Now, the fourth was the concentration of what? The pure acid in grams per dm cubed. We are now asked to calculate this 5.0 grams in 500 cm cubed to what? Change it to what? To dm cubed. That is what? Grams per dm cubed. That is what it means. Now, the fourth one is we are asked to calculate the percentage of purity. You see this question? It's a hidden question, all right? It's a hidden question. Why I brought this question is because, one, in the yellow paper, we are asked the purity of the tetraozo sulfate acid. And anytime you see a purity, something having a yellow paper coming out with purity like that, of course, percentage of purity is always asked. That is why I brought this question. And now, I'm going to, in the equation, look at the equation here. When I'm solving, am I likely, if there is time, am I likely hide this one? I can say that this one or this sodium hydroxide can be what? 2x OH. which we will be asked to find the value of what? Of x. We'll be asked to find the value of x. Are you listening? Are you following? Are you following? Is someone following? Is someone following? Is someone following? You are following. Can we continue? Okay, you are following. Beautiful. Please just make sure you snap this one now, because we are going to wipe it. We are going to wipe it and continue with, firstly, we are going to prepare our table. If you are a teacher, for all teachers, you can as well DM, you can private chat me. If your children or your student are more than 10 or 20, if you are finding it difficulty in preparing the table, you can as well chat me up when I prepare table, so that the table will not be the same. Because if table are the same in maybe 50 students, 30 students, they will be suspect. They will suspect that it is malpractice that is going on. So the table must valid. So if you are a teacher watching me right now, after that, if you have difficulty in preparing tables of to and give to students, then you chat me up. I will prepare this. The titration is expected to be done before the day of the exam, so that the student will have their endpoint. All right, so that during that day they will just do formality, because the exam is just 2 hours to write what 3 part of the chemistry. Are you following? Are you done, so that I can wipe it? Are you done? Are you done? Are you done? You can as well like. I like. Okay, thank you very much for those who are liking. Can we wipe the board? Can we wipe the board? Can we wipe the board? Can you comment that we wipe the board, so that I continue? Are you done, so that we'll proceed? Are you done, so that we'll proceed? All right. Let us proceed. Now, just remember the topic, the question we are asked. We are going to calculate all this one. So I'm wiping the board now. I'm wiping the board now. Now, before wiping the board, what I will do is that I will write my A here. I will write A is equals to what? 5.0 per 5.0 per 500 cm3. That is my A. My B is given as what? 4.0. Okay, B is equal to 4.0 grams cm3. So I have my A, I have my what? My B. I can now wipe. All right. All right. So we can proceed. Now let's see how we can solve it. Now, what we are going to do now, I don't know, some persons already know how. I have already prepared table, but let me prepare the table again. Now the table is, you have to write your burette reading. We have our rough, as the case may be, rough title. We have our first title. We have our second title. We have our third title. All of them are in what? In CMQs. Please just take note of that. Now here we have our final reading. We have initial reading. Final must come come first, initial reading, and we have volume of acid. Volume of acid used. So what I expect you to do, if you are a student watching this video, you can as well let your teacher know, because in the report form, you are going to write the concentration of the acid, the grams of the mass of the base. So if your endpoint is not within range, you might be penalized for that. The endpoint this year we are going to look at here. So initial, before I do my titration, the rough is what? 0.00. That's 0.00. In fact, there's a video called How to Perform Titration. If you finish now, you can go and watch the video on how to perform titration. You will know how to report this in, so that we have a lot of things to do, okay? We have a lot of things to do, so I will not waste time. I will just fill in the table. So now, in the table now, I will say that my rough should be what? 14.00. And at the end, minus 14.0 minus 0.00, you have what? You have 14.1. Do you get that? Now, you can't. Some persons, if you don't want stress, you can write 14.00. But ideally, if you titrate, remember that burette is calibrated from 0 to 50. So when you titrate and reach 14, the acid has not finished. You can continue from there. All right. And when you continue, there will now be a what? Second. But for the sake of people who it means that if I'm starting a fair, it means that if I titrate and get the first endpoint, I have to refill my acid again. I titrate and get the second point, I refill my acid again. That is what it means. So that's what I'm going to do now. So I refill my acid again to be what? 0.00. And at the end, I have 12.70. 12.70. Give us 12.70. Are you following? I will now refill my acid again. If I refill my acid, is what? 0.100. Then here I will now have 12. This one is just estimate, but that is your endpoint. 12. Let's just say 70. Remember, on no account should you write 12.75. If anything like this, if you write anything that has to do with numbers here, not 0, either 1, 2, you'll be penalized. It means that they are going to subtract mass. So you don't use this one. The value that should come after a number here should be what? Should be 0. Why? Because a burette reading is only after the 12, you have 0.1, 0.2, 0.3, 0.4. Copy the table, copy the O. Copy the table, copy the O. I'm so sorry, the network is bad. The account number is 30. Oh, you want to support me? Thank you very much. So, what person want to support me? Oh, if you want to support me, that is that. This one is not by force. If you want to support, you can support. Network is still bad. I'm messed up now. I want to treat this thing. Is network still bad? Is network still bad? Copy the table, copy the table. Network is still bad. Okay, it's better. All right. Thank you very much. Thank you very much. You can copy the table, so that we can start. After now, we are now going to sort analysis. Network is still bad. It depends on your network. The network was bad in my side, but I've rectified it. Okay, beautiful. It's better now. Beautiful, beautiful. Beautiful. Copy the table. Are you done with the table? Copy the table so that we proceed. After now, we are going to look at salt analysis. We are going to look at salt analysis. All right, that is beautiful. We are going to look at salt analysis. Copy so that now the first thing after your titration is to look for your average volume of acid. Average volume of acid is abbreviated as what? VA. That is your average volume of acid. And for you to do that, you say average, which is the first one. We are solving the first one now. Average volume of acid is equals to average, means you add multiple factors. So we have what? We are going to look at first titer, second titer, and third titer. All right. So, but you can as well in I hope the work is okay. Okay, you join late. I'm so video will be here. Okay, we'll be safe here, so you can. Okay, I should repeat now. If you should write 12, is that what will happen is that burette, we have the burette is calibrated 0.00, 1.10, 1. Maybe 1.2, 1.3, 1.4, 1.5, 1.6, 1. There is no 1.45 or 1.12. So if you copy that now, you are going to be penalized. And if any examiner is marking your script and he sees anything that is not zero at the end, and you must always leave it in 2 decimal places. Don't always leave it in 1 decimal place. All right. We that we are marking Waec, that's what we normally look at. If you look at it, child is putting a value of 12.7 without 12.70. We are deducting marks. All right, that is how it is. So you must always leave it in 2 decimal place. And when you are leaving in 2 decimal place, the next one should be after the first decimal place. The next one should be 0. If you write 7.5 or 7.1, you will be penalized. Do you now understand? You understand now, right? Lawson, do you understand? All right. That is beautiful. So we are now going to calculate our average volume of acid. Average volume of acid is what? First titer, first plus second plus third. You are going to divide by what? Divide by 3. First titer, second titer. We are using the first titer and third titer. You can as well first and second divide by 2 without not using third. You are still fine. All right. You can use first and second. You are still okay. All right. Let's be fast. Beautiful. Can we proceed? So here we have first, second, and what? And third. So what we do? We are going to wipe. Please remember this question. Now, the average volume of acid will be what? Average volume of acid, you say VA. Remember, after everything, just bracket and put the word CMQ. Very, very important. The VA will not be what? The first item, look at. Average volume of acid means that you are using the volume of acid. Don't come and use the one of up. Volume of acid, this is the value that you are using. All right. So here we have 12.70 plus what? 12.70 plus what? 12.60. You divide by what? Divide by 3. VA will now be equals to what? VA will now be equals to what? No, I say it's not a must. It's not a must, but what you should do is that, please take note of this. There must be a concordance. You see my value, 70, 12.70, 12.60. Don't write here, after the first title, you have 12.70. Second title, you now come and have 13.7. It is not a concordant. You will be penalized for that. So you must have what we call a concordant. The value must be what? At the same range. Do you understand? The value must be at the same range. That is what we call concordance. And you can as well use first and second, because first and second is what? Is the concordant, is the one that are more close. But you can use the 3. All right. So, but if you have 14 here, you now come and have 12 here, you now come and have 13 here. It's a wrong titration. Are you following? So you have to be very, very careful. Are you following? Can we proceed? So our answer will be what? 12.7 plus 12.7 plus 12.6 is equals to 38. No, you don't have to use rough data. Don't use rough data when you are doing your this. Don't use rough data. In some exam, you can as well cross it like this. In some exam, you can cross it like this. So we have what? 38 divided by what? 3 equals to 12.6. We have 12.67 cm cubed. So our VA, we say VA is what? 12.67 cm cubed. That is our value of our VA. Yes, it can be 0.2. Yes. 0.2. Please, that concordant value is very, very important. That concordant value is that if you do a wide range now, you'll be penalized. It's mostly 0.1, 0.2. Look at, we have concordant value should be what? 0.1, 0.2. 0.3 is not really 0.3 means that if you have here 7, here you are having like, if here is 7, 12.7, here should be what? 12. You add there, it should be what? 13. 13 is too much. So it cannot be what? 13. All right. So the range must be what? 0.1 and 0.2. Like here, in the case of this one is what? 0.1. 0.1. The difference between this one and this one is what? Is 1. 7 minus 6 will give us 1. So it is what? 0.1. 1. You can as well write 0.1, 0.2, but no 0.3. So if you write that, you'll be penalized. Beautiful, beautiful. That is great. How is the rough title gotten? The rough title. Now you get the rough title. When you are doing your titration, you don't just go direct and do the first title and second title. So the rough title, you just titrate, and when you titrate the acid and base, and it gives you, by then you are not too careful. You are not too careful. You now discover that okay, the endpoint have reached. You take your value. That is what called rough title. Now at that point now, where the rough title is, like for instance, the rough title is at 14. When I'm titrating again, I have to be very, very careful. I make sure I'm very, very careful in such a way that I don't make mistake. I have to be so visible in such a way that the color change, I have to observe it very well. That is why the rough data is always different from what? The first, second, third. This one is just rough. You are just doing it like that without not being careful. All right. No, your initial must not be 0.00. That was what I was explaining. Maybe you came late. I told you that this one that I'm saying 0.00, I didn't want to confuse you. If you see what I uploaded on my YouTube, if you see the video I uploaded, my initial are not this. When you have your burette is from 0.00 to 50. When you put your acid there and titrate, after titrating, probably you have your endpoint at 14. There is no point of you refilling the acid since there are still acid there. Are you following? Now, if you want to do it ideally, this 14.00 would have been our initial of the second. Are you following? Would have been our initial of the second, but I didn't want to confuse you. If you check the real video, go to my YouTube channel. All right, you can say how to perform titration. How to perform titration. All this one is being explained. Can we proceed? Can the third titer value be greater than the second and the second? No. The third titer should not be greater than. That is why you have to be very, very careful. Okay, the video will be safe. All right, the video will be safe. Okay, the video will be safe. Now let's proceed. We have gotten our VA. All right, our VA as what? As 12.67. Is that understood? Our VA is what? VA is equals to what? 12.67. Now, what is our VB? VB is equals to, I told you is what? You always use this thing that you use in sucking the base is what? Your VB. And the one normally mostly used in the laboratory is what? 25. 25.0 cm3. 25.0 cm3. The one normally used in the laboratory. All right. Can we proceed? I want to wipe the table so that we'll proceed to the first calculation. Can I wipe the table? Sorry, it was a glitch of. Number one of the questions we are asked to calculate what? One of the questions we are asked to calculate what? I've just wiped is. One of the questions we are asked to calculate the concentration of B in moles per dm cubed. Concentration of B in moles per dm cubed. Now, concentration, look at concentration of B in mole per what? dm cubed. Now, moles per dm cubed has two formulas. Moles per dm cubed has two formulas. One of the formula is molar concentration is equals to mass concentration over molar mass. That is one of the formula. The second formula is CAVA over CBVB is equals to LA over what? LB. These are the two formulas you can use to calculate your concentration in moles per dm cubed, concentration in grams per dm cubed. Now, concentration in moles per dm cubed is called molar concentration. Concentration in mole per dm cubed is called molar concentration. While concentration while concentration in grams per dm³ is called mass concentration. Concentration in moles per dm³ is called molar concentration, while concentration in is not clear. You say you don't understand? Where? I said that we are asked to calculate concentration of B in moles per dm³. Now there are two formulas to calculate concentration of what? Concentration in moles per dm³. One of the formula is molar concentration is equal to what? Mass concentration over what? Molar mass. The second formula is what? CAVA, CBVB, NA over what? NB. Now, which formula are you going to use? Which formula are you going to use? I want to explain the place that you can use this formula and the place you can use this formula. Can I proceed? Can I proceed? Can I proceed? Should I proceed? All right. Now, anytime you are given, look at the question here. A is per cm³, B is grams per dm³. Now, none of the concentration, none of this one is given in moles per dm³. Anytime in the question, one of the concentration is given in moles per dm³, you go straight, you don't use this formula. You go straight and use this formula. I repeat, anytime in the question, look at the question. A is given what? 5.0 per cm³, while B is what? 4.0 grams per dm³. Now there is no moles per dm³ in either A or what or B. When you are now asked to calculate concentration in moles per dm³, you are going to go direct and use this formula if one of the concentration is given in moles per dm³ in the question. But if none of them is given in moles per dm³ in the question, like in this one now, there is no moles per dm³ there. You use this formula for the first one and use this formula for the second one. Do you understand? Yes, that's what I'm saying. If none of the concentration is given in moles per dm³, you use this formula. All right, you use this formula first, but it now depends on the equation. But because there are sometimes they can give you equation and I will say X, which you cannot use this formula because S is not an element. This molar mass, you have to find the elements. All right, now we are going to use this formula for the first calculation. Using this formula, we are asked to calculate concentration of what? B in what? In moles per. What is our B? Look at B here. Do you get that? So we are going to say that using this formula, molar, we are going to make because concentration is what? Molar concentration. Say molar concentration is equal to what? Mass concentration over what? Molar mass. Now concentration in B now, concentration of B in mole per dm³ now will be equal to, what is your mass concentration? Look at, I told you that mass concentration is expressed in what? Grams per dm³. And here we have what? 4.0, that is 4. Divided by, what is your molar mass? Molar mass of the base is what? This one is what? N plus is what? Concentration of B in moles per dm³ is equals to what? Is equals to 0.10 moles per what? Per dm³. Please, after always put your units. So at the end we have 0.10 moles per dm³, and that is what we use to determine our endpoint. Take note of that. This question that I've said is calculated. This question was calculated. Thank you very much, Falamon. Falaman, thank you very much. Can we proceed? Now the next question is calculate the concentration of A in moles per dm cube. I. Concentration of A in moles per dm cubes. In moles per dm cubes. We are asked to, now we have used this formula to calculate this one. We are now going to use this formula to calculate this one. You cannot use these two formulas for the same. Use this one to calculate A and use this one to calculate B. No, if you have used this one, you go ahead and use this one. All right. And in this one now, the concentration of CB and CA must always be in moles per dm cube. Don't go and use the concentration in grams per dm cube and fill here. If not, you're going to have a wrong answer. Thank you very much. Thank you very much. For those who have liked, thank you very much. For those who have support financially, thank you very much. Can we proceed? Can we proceed? After now, we are going to do SWOT analysis. So you have this class is going to be 2 hours class. So you go and recharge. Make sure you recharge your device. Thank you very much. Tell me talk about. Thank you very much. All right, let's proceed. Now, I have told you that you use this formula for the first one. You are not going to use this one for the second one. What do we do? We say that CAVA over CBVB is equals to what? NA over what? NB. Now we are going to make A, concentration of A, make this one subject of formula. So it will be equals to what? Will be equals to CA now will be equals to what? We are going to cross multiply. Look at the one that has the highest parameter will be what? Oh, you are removing this one now. Since you remove this one now has 2. So this one now will now go up that has 3. So will now be what? CB VB NA over what? VA NB. Now what is your, we have gotten our, look at VA here 12.67, NB here 25.0, and what? Mole ratio. Mole ratio of acid. This one is Na is mole ratio. Now what is mole ratio? Na. Mole ratio is what comes in your equation. Look at our equation here. I hope you are following. Acid and base. 1 mole or what? 1 mole ratio or what of acid give you what? 2 mole ratio of what? Of base. What is in front here is what you are seeing 2. What is in front here? Nothing. This one is like 1. This one is just 1 because you are not seeing anything here. So it's 1. Here you are seeing what? You are seeing 2. So here is what? 1 is to what? Is to 2. Please don't go and use the one of the products. We are not, our concern is not of the product. We are looking at the what? The reactant. Base acid. So acid has a mole ratio of what? 1. Base has a mole ratio of what? Of 2. So Na is what? Na is 1. Na is equals to 1. And Nb is equals to what? Is equals to 2. Now we now go and plug our acid. So we now say Ca now will be equals to, I hope you are following, you know. Thank you very much. Thank you very much. Can we proceed? Okay, someone is asking to see the question. No, this is predicted question. Oh. And if you check my YouTube channel, all my predictions are always to the point. Now, we have what? What we have here is Ca now. CB what? What is the concentration of? Look at CB. Concentration of CB is what? Look at. Concentration of B is what? 0.1 multiplied by, what is your volume of base? Volume of base is what? 25. Multiplied by, what is your mole ratio of acid is what? 1. You divide it by what? What is the volume of acid. Volume of acid here we have what? 12.67 multiplied by what is the mole ratio of base? Look at it here. Mole ratio of base 2. So C be equals to, let's calculator. So we have 0.1 multiplied by 25 is equals to, we have 57. 0.1 times 25. What's the one? We have 2.5. 2.5 divided by 12.67. 12.67 times 2 is equals to what? 25.34. So we are CA now. CA now equals to, what do you have as your answer? 2. Yes, so please, there is mark. There's always a mark assigned to it. The final answer is 0.9 moles. Beautiful. Joy, thank you very much. The final answer is 2.5 divided by 25.34. 0.09. So you are going to approximate it. 0.09. Please always leave this one in 3 decimal place. All right. So, but this one we have 2 decimal, so you can add 1 0. Always leave it in 3 decimal place. So here will be what? 8, 9. Look at that. So moles per dm what? Dm cubes. You are done with that. You are done with that. Beautiful. You did on your calculator. Beautiful. 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 You are following. That is great. That is great. So can we proceed? Right. So that we proceed. My concern is just to solve analysis. The next one is concentration of the pure acid in grams per dm cube. Concentration of the pure acid in grams per dm cube. Yeah, you can approximate. We have done approximation here. We just did approximation. All right. We just did approximation. All right. So can we proceed? So we now go to the the third one. Yes, you can approximate. The third one say concentration of the pure acid in grams per dm cube. So fourth one now, we have concentration of A in grams per what? Dm cube. Now listen. This one, that is where some students used to get confused. By the time they ask you concentration, we have said that concentration is what? Mass concentration is equal to, you multiply this one. Are you following? But in this case now, please take note. A is given in what? 5.0 per cm cubed. Per cm cubed. It's not given in grams per dm, per cm cubed. Therefore, you cannot say that molar concentration is equal to, you make mass concentration. No, if you use that formula, you fail. So you are going to change this one now to dm cubed. How do you do that? You say that 5.0 divided by, look at 500. multiplied by what? 1000. This one is in cm cube. So to change it to dm cube, that is what you are going. Don't go and use this formula. Anytime you see concentration per cm cube, don't use this formula. Use this method to get the one of what? dm cubes. Grams per dm cube. Sir, please, I'd appreciate more if you do that sort analysis practical before the theoretical aspect of it. Of course, I'm going to do after this class. We are just left with one question. We'll go to sort analysis. All right. So now, what we're now going to do is that cancel here, cancel here, cancel here, cancel here. So here will be what? Here will be 50 divided by what? 5 equals to what? 10 grams per what? Per dm cubes. So the concentration of A in grams per dm cube is this one. The next question is percentage purity. Percentage purity. Beautiful. The next one, which is what? V is what? Percentage. Percentage. All right. Percentage purity. Percentage purity. Percentage purity. We are going to look at percentage purity. In your question, we have percentage purity. So this one, Ca, is equals to what? 0.099. Cb is equals to what? 0.100. So just take note of that so that I can wipe. So without calculate, after this one, after this question now, we now go to what? To our sort analysis. Go to our sort analysis. Which part you don't understand? Which part you don't understand? Someone said that this, I don't understand this part. Which part now? Which part? Okay, percentage purity. Don't worry. So percentage purity is equal to what? Is what? Mass concentration of pure acid over mass concentration of impure acid multiplied by what? 100 divided by what? 1. Of course, it's just like that. This is how to calculate percentage of purity. Mass concentration of pure acid divided by mass concentration of what? Impure acid multiplied by what? 100. The predicted question. Let me finish the percentage purity. You can as well, as you are tapping, you can like the video, please. All right. Now let's proceed. Now, please take note. Mass concentration of pure is the one you have in your question. Mass concentration of pure is the one you have in your question. The one of impure you are going to calculate. The one of pure is this one. The one of impure, you are going to use this formula to calculate the one of impure. Are you following? The one of pure acid is the one you have in this question. And remember, mass concentration is given in what? Grams per dm. So look at the one of pure acid here. The impure, you are going to use this formula to what? To calculate. So we say that mass concentration of pure is equals to what? Is equals to 10 grams per what? Per dm cubes. Now, mass concentration of impure is equals to, look at, you are going to use this formula. What do? You cross multiply because you are looking for mass concentration. Cross multiply. So it will be what? Molar concentration times molar mass. So he say molar concentration multiplied by what? Molar mass. Remember, whatever you are doing of acid. You are doing the one of what? Of acid. So take note of that. Are you following? So now, what do? Mass concentration of pure, molar concentration of acid is what? Look at it here. 0. But molar mass of H2SO4 is equals to what? 98. Alright? Therefore, mass concentration of impure will be equals to what? What is the molar concentration? Look at molar concentration. 0.09 times what? 98. So equals to what? What do you have as the answer? What do you have as the answer? Let's do so that we can go to salt analysis. Please, so you can screenshot. What do you have as your answer? 0.099 times 98. Beautiful. 9.7. We have 9.70. So what? 9.170. Alright? Grams per what? dm cubes. Okay? So now we now plug it into our formula. What do we have? If you plug into your formula, we say percentage of purity will be equals to what? The one of pure acid is what? 10. 10 divided by the one of impure is what? 9.70. Multiplied by what? 100. So what we have? 1000 divided by this, of course, will give us what? Yes, you can see after the beginning. Alright, I will save the video so you watch it. 10 times 100 divided by 9.70. So percentage purity will be what? 10. Beautiful. You are always on point. Joy. I'm so sorry. Blessing or blessed. All right. 103.09. So we have 103.09%. So that is the end of our practical. Please, that percentage purity is very, very important. Percentage purity. And we work with estimates now. We work with estimate. That is why it is like that. All right. We work with estimates. That is why it is like that. Yes, I'm going to drop the video. But that is how to calculate percentage of purity anytime you are given, all right? Anytime you are given, that is what you are asked, that is what you are going to do. Okay? It didn't start from the beginning. Yes, we said that we work with estimates. That is why it is like that. But anytime you are asked, that is what we have now. Look at percentage of impure is what? Molar concentration. What is the molar concentration of acid? Look at it here. Molar concentration of the acid. Now, what is the molar mass of acid? Is this one. Now, at the end, if you multiply this one, give us this one. We are just working with what? With prediction. You understand? We are working with what? Prediction. So now, this is what it should be expecting. Alright? So the important thing is that just know the steps. Is that understood? Oh, I'm so sorry. Let me plug my light now. I'm going to do the, you are going to rewatch, all right? Can we proceed? It's now for salt analysis. Oh. It's time for salt analysis. I want to wipe the board now. I want to wipe the board now. Should I wipe the board? No, see this video will be saved, all right? You can go back and watch it again, okay? So let me proceed to salt analysis. Salt analysis. For those who feel like supporting, look at the account number here. If you feel like to support, you can support. So, salt analysis. Let's do salt analysis. You know, salt analysis is direct. Salt analysis is always direct. You already know the question they are going to set. So that one is just for you, even though you don't go to the laboratory to do your test, it's just for you to practice the question. Salt analysis is direct. So what I'm going to teach you now, just expect it direct. Yes, I remember you. Now, in salt analysis, what you should know, you are always given the salt we are asked to analyze is what? Carbonate and starch. Carbonate and starch. We are asked that we should measure this one in a ratio of 1:1. 1:1 means that if you measure this carbonate 2 grams, you must measure starch 2 grams. If you measure this lead 2 carbonate 1 gram, you must measure starch 1 gram. You mix it together. Do you understand? He said we should mix the two things together in the ratio of what? 1:1. 1:1 means that if you measure this one 5 grams, you must measure this starch 5 grams. When you do it, you mix it together. Alright? Now, in your salt analysis, there is always a format in which you are going to report. What is the format? We have what we call the test. We have the test. We have observation. And we have a forward inference. We have the test, observation, and inference. Are you there? That is very good. That is very good. Yes, that is the real. That's what I'm saying now. Salt analysis is easier to predict. Now listen. Among the 3 aspects of the practical, we have titration, we have salt analysis, and we have test of chemistry. The one that is direct to predict is this one. So whatever I'm giving you now, just make sure go and read it. Highest, they will just turn it. Alright, they will just turn it, but the way it will turn it, it will still come out the same. So this one is more easier to predict than any other one. The only way you can predict the other one is the endpoint and table. Then, of course, you know how to calculate your most specific and graph specific. But this one, it is direct. Can we proceed? Thank you very much for those who are liking this video. Thank you for those who have support by sending small cash. I really appreciate. Can we proceed? Can we proceed? Can we proceed? All right. Now, this one now, a mixture of this one, they cannot give you. It is only teachers that they will give this one. In the green paper, it is only teachers that have this one. So you as a student, you don't have this one. So they will label this one. They will take it as what? As C. They will take it as what? C. Okay? They will take it as C. So, having mixed this one now, firstly they will say C plus, remember, C is a mixture of this lead 2 carbonate and what? And starch. So they will ask you C plus water. Maybe distill water, as the case may be. Distill water and mix. And mix thoroughly. And mix together, sorry, and mix together thoroughly. Mix. And mix together thoroughly. We are asked to do what? Check. Just we are asked to mix those things together thoroughly. Okay, from Ghana. From Ghana, thank you very much. Please do well to subscribe. If you have not subscribed, please do well to subscribe. So C plus distilled water and mix thoroughly. Now when you mix it together, your observation will be what? Now a mixture, this lead carbonate is not soluble. This starch is not soluble. It means that they don't dissolve in water. If you put them in water, they will not dissolve. That is what it means. Do you understand? Are you following? Now, since it is like that, when you mix it like that, what you are going to see is say C is insoluble in water. Is it soluble in water? And white solid is observed. This is what you are going to report. This C now, it is insoluble. C is insoluble because what? Lead-2 carbonate is not soluble. Starch is not soluble. So that mixture is what? Is insoluble. So after you dissolve it, what you are going to see for of course I've carried out the practical, you are going to see a white solid is being observed. But firstly, C is insoluble in water, and what? A white solid is what? Is being observed. Do you get that? So in your inference now, you say C is a mixture of insoluble substance. You cannot say insoluble salt because starch is not a salt. This one is a salt. This starch is not a salt. So you say what? C is a mixture of what? Insoluble substance. And every stage that you complete, rule your line. So we are going to rule our line. You see this first part, very, very important. No, it will not form a collider. Okay, that is insoluble. Okay. A substance that does not dissolve in water is not called a solution. No, there is no specific volume. They will just ask you to dissolve it. Yes, that is how you will likely see it. I say this one is easier for you to predict. Yes, it will be given for you to fit the observation, inference. Now listen. A solution cannot be formed. You cannot say a solution. A solution is when something dissolves in water. That is why we have a true solution and a false solution. Anything that is solution means that thing is able to dissolve. If it dissolves partially, it means that is of course that one is partially soluble. But if it doesn't dissolve at all, it's not called a solution. A solution is formed from what? A substance, a solid must dissolve in what? A solvent. If a solid dissolve in a solvent, you call it what? You call it a solution. So that is why we didn't use a colloidal solution. Alright? So it's not a solution because of what? It does not dissolve. That is one thing you should know. Now the next thing is that you will be asked to treat this C because of what? The presence of this carbonate. This carbonate is a gas. It will produce always what? A gas. So you'll be asked to treat this solution with what? With acid. I don't know whether I'm making sense. Are you following? Can we proceed? No, sometimes Waec will give you the table, and sometimes you will be asked to draw the table. All right. Sometimes the text portion is always written. Can we proceed? Now, the next thing is C now plus dilute HCl or H or HNO3. Now, that is why I say that this one is direct. Now, it depends on how they will ask you. They cannot ask you to use HCl and use HNO3. One must be given. It is either you use HCl or use what? HNO3. I will explain why. I will explain why. When you use HCl, look at what happens. If you put HCl, look at here, we have P. Now remember, starch does not react with any acid. Starch does not react with any acid. Someone came to my comment section and said that starch will react with acid. How will starch react with acid? So you have to read your chemistry very well. So now Pb now CO3 plus, if you react with this one plus HCl, what you are going to see is what? PbCl2 plus what? What is formed is what? Carbon dioxide, carbon 4 oxide plus what? Plus H2O. So here is what? 2. If you react this one with what? HCl. Now, if you now react this one with PbCO3 plus HNO3 will give you Pb bracket NO3 bracket 2 plus CO2 plus H2O. So here we want. I'm about to do something very, very interesting. But H2SO4 is used as a dehydrating agent. No, you cannot use H2SO4. Do you see H2SO4 there? I'm tired. Now, I told you, after this step now, you will be given this salt. You will be given this the mixture, that is what you have dissolved, to be treated with what? To be treated with either HCl or what? HNO3. They cannot give you the two. They will either give you this one or give you this one. Do you understand? Now, if they give you this one, look at the equation here. This one now is insoluble. White PPT, white precipitate, and it's what? It's insoluble. And since it is insoluble, you need to heat it. If you heat this one now, PbCl2, you heat it to give what? Pb2 plus what? Cl minus. That is what it's going to be. That is why if they give you HCl, they will ask you to heat it. If they give you HCl, they will ask you to heat it. But if they give you HNO3, they will not ask you to heat it. This one is soluble. Look at this one. It's a soluble salt. This one is not soluble. So you need to heat it in order to what? That is a chemistry behind it. So if they give you HCl, you will be asked to heat it. If they give you HNO3, you will not be asked to heat it. Do you understand? Amen. Thank you very much. I don't know whether you are following. Can we proceed? I have given you two options. It is either they will give you HCl or what? Or HNO3. Which one will dissolve? HCl will not dissolve. It is HNO3 that will dissolve. Can we proceed? Can we proceed? Yes, they are going to give you the instruction. All right. So now, when you put these two things down, when you put this one down, what you are going to see is, because of the presence of this carbonate, effervescence will occur. Effervescence is bubble. Bubble will start to come out. So you see effervescence. Effervescence is observed. Is observed colorless and odorless gas evolve. That is what you are going to see if you treat this one. But then with this HCl, it will be partially white. With HCl, it will be what? A little bit white. But that is what you are going to report. Joe, let me go back. What do you ask? I'm coming to that side, all right? Francis, I'm coming to that side. Joe, what do you ask? Okay, second equation is not clear. No, you cannot write effervescent only, please. You cannot write effervescent only. You cannot write effervescent only. This yes. Look at, if you add either this one or this one, effervescent is what? Observed. And a gas will be evolved. A gas will be evolved. And that gas is what? CO3, 2 minus is what? Present. You are inferred, that is what you are going to write. CO3, well, this is the gas that will be evolved. This one is present. Now, in the requirement, you are asked to treat this one with what? Lime water. As soon as the gas is coming out now, if you pass that gas now with lime water, the lime water will turn milky. That is to confirm that carbon dioxide is present or is evolved. Let me read your comments. Yes, it's going to capture everything. Please, is the same portion of C that was added with the seawater that is going to be tested with? Yes, Joe, yes. If you dissolve this one with water now in that water now, you now carry that water now. Of course, you use test tube. All this one is carried out in the test tube. You now carry that portion of water now and put small quantity of it in a test tube. When you put a small quantity of it in the test tube, you will now test with what? Either HCl or what? HNO3. When you do that, this is what is going to happen. Effervescent, or let's just say effervescent. Effervescent is observed, and colorless and odorless gas is evolved. That is to show that CO3 ion is what? Is present. Are you following? Can we proceed, sir? You are doing great. Thank you very much. Thank you very much. I appreciate. Now, you will be asked, since the gas is being evolved, you will be asked to pass this gas through what? Lime water. Anytime you see this kind of test, of course, there is no way they will ask you for carbon dioxide. So you say gas turn lime water milky. Gas turn lime water milky. In your inference here you say CO2 gas from CO3 2 minus evolve. This is what you are going to write. Just write that, just write that. In your inference, that is what you are going to write. No, you are going to watch this one, okay? How do you get CO2 gas? Yes, you are going to add that HCl. I will respond to that. Now, let me come again. This mixture. When you carry this mixture and put water in it, this is what you are going to see. White solid will be what? Will be formed. This mixture is insoluble. Alright, so you cannot call it a solution. And at the inference now, C is a mixture of what? Insoluble what? Substance. Secondly, they will now ask you to carry this mixture that is this one that is insoluble in water. You will now carry this thing and put in a test tube. It is not soluble. You will now treat it with what? With either HCl or HNO3. Now when you treat it, what you are going to see is effervescent. Effervescent is from what? From carbonate. Will come out with what? Bubble. Effervescent means bubble. Anytime you open your Coke, any mineral, if you open it, you see gas. You see that gas. That is what called what? Effervescent. Bubble will start coming out. Now that gas is colorless and what? Odorless. If you now pass that gas, as the gas is coming out, just carry lime water, that is calcium hydroxide. Carry lime water that is white. Carry it and put the gas there. That is, make the gas, let the gas touch that lime water. That lime water will turn milky. That lime water that turns milky, it means that CO2, carbon 4 oxide, from what? Carbon 4 oxide is being evolved. That gas that you are seeing there is what? Carbon 4 oxide. And where that carbon 4 oxide coming from? It's coming from this triazocarbonate ion. Do you now understand? Do you now understand? Can we proceed? All right, say I should move on. Thank you very much. For those who have supported, thank you very much. For those who are liking this video, thank you very much. For those who have made, for those who support by cash, for those who wish to support, there is the account number there, 30 48 039 140. Thank you very much. Now, let's proceed. One thing I told you, if you use HCl, we are going to treat HCl first. If you use HCl and add, this is what is going to form. This lead chloride is insoluble. Therefore, you need to heat it. Are you following? You need to do what? You need to heat it. If you don't heat it, there is no way this lead. Now we are now going to look at the test of lead ion. What are you asked? Look at BB2 ion CO3 ion, CO2, and what? And starch. These are the three things. 1, 2, 3, 4. Now we are done with this one. It is now this one and this one that is now left. Now for you to be able to get this one, you have already treated with this one. When you put this one now, when you put HCl, you need to heat it. Why do you need to heat it? For you to be able to want to split this ion. Look at, so that lead will be alone. I'm giving you this so that in case you are asked in exam to use HCl, if you use HCl, Waec asks you to use HCl, you must heat it. That is sure. If you don't heat it, there is no way you get your result. It is only when you use HNO3 that you don't need to heat it. And of course, I've given you this one. This one is soluble, this one is insoluble. All right, beautiful. I can see that some people really comprehend. Some people already understand. Can we proceed? Thank you very much. Thank you very much. Can we proceed? Talk now so that we proceed. Okay, someone say we should just proceed. Now, we are going to treat with this one now. If you use HCl, we are going to use HCl. If you dissolve this thing with, if then you ask you to use HCl. So what you are going to do is that you say filtrate. When you add HCl now, of course, effervescence will occur. And of course, there will be small white precipitate. White precipitate will be formed if you use HCl. I don't know whether I will even write it here. Small white precipitate is formed. Now, you will not ask to filtrate. You will, of course, when it happens like that, you need to filter it small. Alright, filter because the mixture contains starch. So starch will go down. If you put any of the acid, starch will go down. That starch is called residue. That starch is called what? Residue. If you add either HCl or what? Or HNO3, it will go down. Starch will go down, while the other one will go up. So you now decant it. We decant it or we call it filtrate, alright? But in ordinary sense, you can decant it or what? Or you filter it. But that one is not really filtrate. But starch will go at the bottom, we call it residue. So that as you filter now, you say filtrate plus heat. We say filtrate plus heat. That this one, listen, Waec will always give you this test. Your own portion is this observation and inference. They will always give you this one. This instruction is always, so they will always tell you do this one and this one. So this one is, you don't have any business with this one much. Your business is is with observation and inference. Do you understand? So it says filtrate plus heat, then cold. When you heat this one now, what you are going to see is that white precipitate dissolve. White precipitate dissolve. When you now allow it to cool now, you see precipitate, I will just say precipitate reappear. Reappear on cooling. By the time you heat it here, the precipitate will dissolve. That is, I've shown you how the equation is. Like now, PbCl2. If you heat this one now, what you are going to see is Pb ion plus what? Cl minus. So this precipitate now, it will dissolve. That dissolving will give you what? Look at it here. But when you now allow it now to cool now, it will now do what? It will now come back. That undissolved substance will come back again. Now, that's why I'm coming now. I'm just treating this one HCl first. I'm coming to that HNO3. I'm coming to that HNO3. Are you following? Now, what behave like that is what? You are going to say lead ion Pb2 plus present. Now, if they give you the one of HCl, after this step, this is what you are going to do. Then the next step now has the one of HCl or HNO3. If it is HNO3, you go direct to this one I want to explain now. If it is HNO3, you go direct to the one I want to explain now. Now, if it is HCl, you are going to pass through this stage. But if it is HNO3, you are not going to pass through this stage. Is that understood? What about if they start by telling us? That's what I'm saying now. If they start with the other one, you will not pass through this stage. It is better I teach you the both, so that in case they give you the both, you have to know. It's better for me to teach you the both, so that you not go and hope on one. At the end, they will not give you another one. You have marker. Offering, you have marker, send me now. Look at the account number there. You can send it. The residue is not gas, so the residue is stash. The residue is stash. Offering, if you want to give marker, look at the account number there. All right, okay, someone say you have understand. That is beautiful. They can ask you to separate it. They can ask you to divide the mixture into two test tube, into two portions. The other one they will ask you to treat with the HCl. The other one they will ask you to treat with HNO3. Understand? Someone is asking whether they can ask you to do the post. Now they can, to divide the portion. They can ask you to divide this into two. Now the first one, treat it with this HCl. If you treat it with this HCl, this is what you are going to report. Of course, they will tell you the first portion, heat the first portion. What are you going to see in the first portion? The other one, don't heat it. What are you going to see? So if they ask you to treat with HCl, this is what you are going to see. Do you understand? Now, at the end of it now, these two now that I want to give you, all of them have the boat. Have you written this one so that I can clean? Can I wipe the board so that we'll proceed? Thank you very much. Blessed Okon, thank you very much. I should create a group for that. I'm just explaining now. Let me explain. After this stage, after the first stage, the second stage, you will be asked to treat either with HCl or HNO3. If they ask you to treat with HCl, you are going to heat it. They will tell you after adding HCl, heat the mixture. If you are treating with HCl, you heat the mixture. When you heat the mixture, that is what you are going to see this. It says filtrate. After this one now, you are going to filter it to get the let starch be, of course, starch is residue. You now get the supernatant, that is the upper one. You now heat it if it is HCl. When you heat it now, what you are going to see is this. Alright? While precipitate is will dissolve. Now precipitate will reappear on what? Cooling. When you allow it to cool, all this information will be given to you. Now when you are now asked to treat with HNO3, if you add HNO3, this one will give you a clear solution while starch will settle. But if it is HCl, it will not give a clear solution. It will give a cloudy solution. Do you understand? Do you now understand? Starch is insoluble. Starch is insoluble. Starch does not react with acid. Starch does not react with acid, so starch will remain as residue. Can we proceed? Yes, I'm going to release this video after the live. I want to wipe this side. Now, after you have treated either this one or this one, the next step, you have two things to do. Either to test it with ammonia or test it with what? With sodium hydroxide. Are you following? So, in your test, I will now have filtrate plus aqueous ammonia. Whether if you are using HNO3 or HCl, in the case of HCl, after reporting it, this is the next step that will follow. In the case of HNO3, this is the next step, the next step that will follow. Do you understand? So now filtrate plus aqueous ammonia in drops. In drops. Then in SS. In dross, what you are going to see is white precipitate. Is formed. Or some people can say white precipitate is observed. Are you following? Is what? Is observed. Now, what is, if it is in dross, white precipitate is formed or observed. Then when you now add it in SS, in SS now is what? Precipitate insoluble. Then that kind of thing that happen like that is what? Lead to ion. In your friend, lead to ion or calcium ion is present. So do the HNO3 on a board. I'll just explain you. I hope you are following. Are you following? Are you following? It's starch granule. Yes, starch granule. Now, it is two that they will ask you. It is either they will ask you to test with ammonia or sodium hydroxide. Now, in the case of, look at that. I told you, if they want you to confirm lead 2 ion, they will ask you to do what? Add potassium iodide. If you add potassium iodide in this solution now, what you are going to see is a bright precipitate that will form. But potassium iodide, it is not in the material, that yellow pepper, it is not there. So since it is not there, you might not likely be given. Alright? Now the next thing is what? Filtrate. Filtrate plus Na plus NaOH aqueous in drops. Then in SS. Now, when you are testing for lead ion, it is either they'll give you this one or they give you this one. I'm giving you two so that anyone they give you, you just go direct. Their own business, what you are going to do now is, even though you don't perform the practice, it's just to go and read. Just to go and read the way they have just done here. Just go and read. It is either they will give you to test for lead and lead ion. It is either you use ammonia or what? Or sodium hydroxide. They will either give you ammonia or what? Sodium hydroxide. So when they give you ammonia, what are you going to observe? If they give you sodium hydroxide, what are you going to observe? So, are you following? Of course, I say this one is just at 98%. 98%. Filtrate. When you put your acid, when you put your acid, if it is HNO3, some, since the mixture contains starch and lead carbonate, starch will go under, so we'll settle that. Then you now decant it. That one is what we call filtrate. Do you understand? Now what I'm going to see here is, say, of course, white precipitate. White precipitate is observed. White precipitate is what? Observed. Then in essence now, this in drops. In essence now, say precipitate dissolve. Precipitate dissolved or precipitate is soluble. So what I'm going to see here is what? Lead 2 ion or lead or calcium ion and what is present. And here we have what? Lead 2 ion is present. Now, for emphasis sake, in case in the future time you are asked to confirm, you say that R plus what? Plus potassium iodide. In fact, let me not put that one because there is no need. I have already posted salt analysis video. Yes, you can answer the question without carrying out the practical. That's what I'm giving you now. Go and read this thing. There is no point of you at the practical, because if you carry out the practical, this is what you are going to see. If they give you both, you do the same. That's what I'm giving you to. There is no way they can give you anything outside this one. They cannot give you anything outside this one because this is the test for lead ion. Are you following? So if they give you this one, you go. If they give you this one, it's the same thing. Do you understand? Now they start test for iodine, and that will be the end of the lab. Thank you very much. For those who wish to support, nothing is too small. You can double tap on the screen to like. Are you following? What you owe yourself is to go and read. What I've just given you now is just for you to go and read. They are going to, in any way you are given, I've just analyzed it and give to you. In any way you are given, that is what you are going to see in your exams. Highest, they are going to frame it. Can we proceed? Let's proceed. Oh, supported. Humphrey, you have supported me. Thank you very much, Humphrey. God bless you, Humphrey. Thank you very much. Thank you very much. Thank you very much, Humphrey. Thank you very much, Humphrey. Humphrey, thank you very much. Thank you very much, Humphrey. Now, the last test, this one, there is no way they can ask you to set it, or they cannot ask you in any other way. This one is just direct. Now, the last one is, the last one is let me load my, this my marker is finished. The last one is test for iodine. Thank you very much. Oh, I'm so sorry, Alfred. Thank you very much. I'm going to post the video after now. Let me fill my marker. Thank you very much. So the last test is test for starch. I've already carried out the titration. For the titration part, I've already carried out the titration. Even the salt analysis I've done in the lab. All right. I'm going to test for this starch. The last one is to test for starch. Are you there? So that we'll proceed. So in the test for starch now, you say portion of original mixture plus iodine. Please note, they cannot ask you to use the residue of that mixture. They will ask you to go and use the original mixture of this one. By the time you mix these two things together, they will ask you to get the original mixture, the portion of that original mixture, to test for iodine. Remember, they cannot give you the one, maybe the one that you have added acid. No, they cannot use that one. They only ask you to go and get the portion of that original mixture. Okay, when you get the portion of that one, you test with what? With iodine solution. If you test, what you are going to have in your observation is a blue, black, or sorry, let me, my light is shaking. You have blue black, some can say blue black, some can say or dark blue, some can say blue black, some can say, many students, more especially for teachers, you can give them, some can write blue black, some can say dark blue. Coloration observe. We have blue black, some can say blue black, some can say dark blue. Coloration observe. So here I say starch is present. Starch is present. That is the end of your practical. That is the end of your practical. That is the end of your practical, sorry. So at the end, we have been able to establish all our salt analysis and titration. It says that the original mixture is, yes, original mixture. Look at, they said you should add this one, the ratio of 1:1. That is lead carbonate and starch, mix them together, so you are going to get the portion of it. Now it's not only starch, oh, it's not only starch. That original mixture, don't carry some of the mixture now, carry the mixture out. They will ask you to use the other mixture and dissolve. Then the other one is that is you don't dissolve, you use it for the test of starch. They cannot ask you to use the one that you have already dissolved in water, no, or use acid, no. Do you understand? Because that one, the temperature have changed. Thank you very much, Francis. Thank you very much. Amen. Thank you very much. Thank you very much. Please do well to subscribe. For those who have not subscribed, do well to subscribe. Thank you very much, Francis. Thank you very much. Confirmatory test for lead. Okay. Since you asked, I told you that in the reagents given, the instruction material they gave to teachers, there is no confirmatory reagent. But what you can use to confirm lead is potassium iodide. In your test, if you are now asked to add potassium iodide either to this one or to this one, what you are going to see in your observation, you are going to see a bright yellow precipitate. This one is what? White precipitate. The other one, if you add potassium iodide, you are going to see a bright yellow precipitate. And in your inference, you are going to say lead 2 ion confirm. Lead 2 ion confirm. That is if they only ask you to add what? Potassium iodide. But it is not in the instruction material. The reagent listed for you to use and do the test, it is not there. So if it was to, if that we have it there in the instruction, we would have added it here. But in case you encounter it, if they say you should add potassium iodide, in your observation here, you are going to see a bright yellow precipitate. Observe, bright yellow precipitate. And in your inference here, you say lead 2 ion confirm. Instead of writing present, you say what? Confirm. Thank you very much. Thank you very much. Thank you very much. Thank you very much for those who have subscribed. Yes, a mixture with this, you add starch. That is our first step. That one they cannot ask you to use this one to use to do your test of starch. Blessed, thank you very much. Success, thank you very much. I really appreciate you guys. Okay, that one I'm just trying, I'm figuring out. Okay, legit school. I'm figuring it out what they will likely ask. All right, what they will likely ask, I'm just trying to see. That one is already, I'm figuring out. I will make a video on that. And for we use HCl to confirm acid. HCl is acid now. How will you use acid to confirm acid? Thank you very much, offering. God bless you. Yes. What I expect you to do, listen, I have given you 2 parts, titration and this one. And one thing you should know about that titration, most per DNQ, grams per DNQ, either A or B, must come out. Just prepare for that. That one, there is no harm. Get your table. Make sure, prepare your table very well. Know how to calculate most per DNQ, know how to calculate grams per DNQ, either of A. Know how to calculate your molar mass. I did not calculate that one on molar mass anyway. If you ask you to calculate molar mass, you make molar mass the subject of formula in your molar concentration is equal to mass concentration over what? Molar mass. Just use make molar mass the subject of formula, which will be what? Mass concentration over what? Molar concentration. That is how to get molar mass. Okay. Now in this one now, what you owe yourself is just to go and study this step. You don't need to go and do practical because Waec cannot give you anything outside what I have just done here. It is either they will give you the one of, if you are asked to test for lead ion, it is either you use ammonia or use sodium hydroxide. These are the 2 things that you'll be asked. And in Jordan, dissolving in the acid to test for carbon dioxide. Now it is either you use HCl or use HNO3, and I've given you the table for that. Then for starch, it is this one, blue-black coloration. Some people will say we heat. How will you heat starch? You say after adding iodine, you heat it. There are some videos that I've been seeing online. I bet you don't know how to watch those kind of videos. You don't heat starch. The temperature that starch is already in the room temperature, so you don't need to heat it. Do you understand? And for those who have supported me, God bless you. I really appreciate. I really appreciate. God bless you. Yes, so bless you. Are ready. Nothing else. So we are going to end our class here. I'm going to post the video, okay? He said, can you use this here to confirm leg? That is what I'm saying now. That is what I'm saying. So I did not give you one thing on Jesus Christ. I forgot one thing. Oh my God. Please go and watch that my video of SWOT analysis. There is one thing I've just missed out. That HCl, when you add HCl to it, then you now heat. What you are going to see is I made something like PbCl2. This is what you are going to see. Why precipitate is formed from lead 2 ion. When you heat it, please go back to that video of my SWOT analysis. Read that video. There's that part I've not forgotten. In that part of HCl, this is what you are going to see report in your inference first before lead ion present. I just omit that part. Lead chloride, that is from lead ion from this one is what present. Just check, just go and marry the video, 2 videos together. All right. Thank you very much. Please do well to go and to subscribe for those who have not subscribed. Thank you very much. Let me just edit the video down and upload it. Thank you very much. And for those who have supported, may God bless you. For those who support by liking this video, for those who support by recommending people, for those who support by sending me some cash, God bless you. God bless you. God bless you. God bless you. Thank you. I'll see you next time. Bye. And for those teachers, if you don't know how to prepare table for your students, just chat me up. Chat me up, okay? I'm watching from Ghana. Oh, thank you very much, Abigail from Ghana. Abigail from Ghana, thank you very much. Thank you very much, Ibrahim. Thank you very much. God bless you. God bless you. Humphrey, thank you very much. I really appreciate your support. Your cash support is very, very tremendous. Thank you and God bless you. I really appreciate you all. Thank you very much. We love you. I love you too, Francis. Francis, thank you very much. I love you too. My WhatsApp number, okay, watching from Nigeria, thank you very much. Now, this is my WhatsApp number. My WhatsApp number is always on my video. We have +234 8134647505. I'm putting plus because of those who might be from other countries like Ghana. I think Abigail is from Ghana. This is my WhatsApp number. If you are a teacher and you find it difficult to prepare, if your students are 100 or 50, I don't know how to prepare table for them, I can assist you that. Just chat me up. I will make a table that will have, that each student will have different table, but at the end they will arrive at the same end point, all right, or the same volume of acid. So you can chat me on that. Thank you very much for your support. I really am very, very grateful. I'll see you some other time. Do well to subscribe to my YouTube channel. Like, comment, and share. Any way you can just help. Thank you. God bless you. Bye. That is my WhatsApp line. That is my WhatsApp line on the board. All right. See you.